Hi, good morning, everyone. Hope you're doing well. Happy Thursday. Um, Hopefully you are watching these videos. On YouTube, I can see that there are some views. Please let me know if these videos are helpful or not. And hopefully you are all well. You're all taking care of yourselves and your families, right? So we're going to continue with differential heating. The difference of heat on Earth based on how the Earth is shaped and where the sun's rays hit the most. All right, and then we're going to move on to the difference in heating between land and water, which creates all the weather or most of the weather patterns that we see on Earth. Right. So let me minimize my face. And this will be the document that I'll be posting on Google Classroom today. So differential heating, that word differential just means there's a difference between heating and the first one. This is just a review of what happens to the Earth's surface. So the equator and the surrounding areas, right down here, the letter B, the Earth or the sun's rays hit this area in a more concentrated manner. So there's more heat here. And as the Earth curves around the poles, the sun's rays are dissipated. You have that word dissipated versus concentrated. They're opposites of each other. Okay, so the sun rays are dissipated. There's less sun rays and more area. And so you have cooler temperatures by the poles away from the equator. So that's differential heating for the Earth's surface. And then when we get to differential heating, difference of heat between land and water, we have uh, a phenomena that happens on Earth where land heats up and cools down much faster than water. Okay, and that has to do with the density of material. The molecules of matter on land are much tightly packed. They're closer together, and on water, molecules are farther apart. I'll add the concept of a video for density on Friday. But basically, land heats up and cools down much faster than water. Okay, and because this happens when land heats up during the day, land will heat up faster, and water will heat up, but kind of be warm. And at night, it cools down much faster too. So what you have is during the day you have hot air because the land. Oh, and at night the water cools down slower, but it cools down. So then when the next morning the water is still kind of cooling and the land is heating. So then with hot air, the molecules in hot air are moving really fast. So because they move fast, they rise. They move away from each other. The density is less, and the molecules of air rises. Molecules of air rise, and the cool air that's above the ocean, because the water is cooling down or actually heating up now during the day much slower than the land. So now it's still cool during the day. The cool air moves onto where the hot air is rising. Okay, so when that happens, you have a sea breeze because cool air is displacing, is taking the place of hot air. Okay, so you have a sea breeze happen, and this is the differential heating between land and water. Again, land heats up much faster, cools down much faster than water, which is slow. Okay, so in Southern California, this is why we have such good weather. During the summer, we have the heat we have on the latitude we sit on Earth. We should have much hotter summers than we do, but because we are close, we're coastal, we're close to the ocean, at least on this side of the mountains. we get that sea breeze because of the differential heating between water and land. Okay, and we're going to go a little bit more into detail in a following video about density of air and density of molecules, and why is it that hot air rises and cool air actually sinks. Okay, so one last thing, we're going to touch on the concept here, but we'll go into detail again when we talk about density, is that cool air is more dense. The molecules are together, so it creates an area of high pressure, and hot air is less dense. Molecules are moving away from each other, rising, so hot air creates an area of low pressure. So high pressure high pressure air replaces low pressure air, and therefore you have a sea breeze. And on land, when that happens, we call that wind. Okay, hopefully this video is informative and not too complicated. If again, please work on these questions, fill them out, create a copy in Google Classroom for yourself and answer these questions, and submit them for points. I'll be correcting your work as we get to the deadlines. Please watch the videos. Let me know what you think. Be nice, and hopefully I will see you soon. I miss you all. Yeah, trust me, I miss you. Miss all of you. All right. Take care and see you soon. Bye.